All right, here's example 1.36 from OpenStax PreCalculus. We're asked to find extrema, local mins, local max from a graph. Now, so you got a graph right here, and you look at this thing, and you're like, well, I guess there's a local minima, I don't know, somewhere in here about. Make it big enough so that it's roughly right. There's kind of this little valley going on right there, and there's a local maxima, I don't know exactly where, somewhere in here. So you could try to kind of ballpark those coordinates, but your answer would be very imprecise. So I think what's going on with this one is the idea is to use technology. So maybe you have a graphing calculator, maybe you got something that looks something like this, and they give us the equation of this function right here. They tell us that this equation is 2 divided by x, so I'll just type this in here, 2 over x, plus x divided by 3. So I'm copying this in here. A lot of students like to go overboard parentheses and throw parentheses around everything, and you can do that if you feel like it, but note I don't have to here because the way the computer will, or calculator will read this, it'll do order of operations. So it'll think about 2 over x is one thing, and x over 3 is one thing, and then I'm adding those things together. So this is, in fact, what I want. At any rate, let's take a look at the graph. Hey, there it is, and it kind of looks something like this picture right here. Your calculator has some handy features for finding local minima and local maxima. They're under the calc menu here, which is above the trace key. So to get into the calc menu, since it's in orange, I guess that is, above trace, I'm going to hit the second button and then hit trace, and now I'm in the calc menu. And here's a bunch of things your calculator can do. The two that will be relevant to us are the minimum and the maximum. Makes sense. I'm looking for extrema. I'm looking for local minima and maxima. So maybe I'll do the minimum first. So I hit minimum here. And so to figure out the minimum, I have to tell my calculator about where it is. And that's for a couple reasons. It's because of the algorithm your calculator uses to find the minima, and also because there might be more than one. And if you were in the case where there were more than one, calculator would have to know which one you're talking about. So the way you kind of tell the calculator where to look is you give it a left bound, a right bound, and then you take a guess. So my left bound, I want it to be some point to the left of where this minima is. The minimum is right here, right where my cursor is. And so I can use these arrow keys to move this x around. And really I have a lot of freedom in where I put it. I just want it somewhere where I'm sure it's to the left of where the point actually is. So I'll leave it over here and then hit enter. And note that the question that it's being asked is left bound. So I'm giving it a point to the left of the point in question. And now I want a right bound. Sure, I can do that. Move this thing way over here. Just to be safe, I'll make sure it's to the right of this point. I could have zoomed in a little bit. Maybe that would have made it easier to make sure I was to the right of this point, but really it doesn't matter. Note I have these two arrows here. So what my calculator is telling me is I, the calculator, I'm going to search in between this region here and find the lowest point. And it wants me to take a guess. It's just because to start the algorithm, it needs somewhere to start. So I'll take some guess somewhere in the middle. The guess isn't all that important. If you do get as close as you can. It really won't make a big difference. Sometimes it'll be off by 0.01. It'll affect rounding error on this. But as long as your guess is relatively close, it won't make a difference at all. So I hit it. This little line means my calculator is thinking, and it estimates this minimum to be at a coordinate at, I hid that. That was a bad idea. 2.45, I guess, if I'm going to round to 2 decimal places, and 1.63. 2.45, 1.63. Note these are not exact values. These are just estimations of this actual minimum here. And I can do the exact same thing. Maybe I'll go a little quicker this time to find these coordinates here. I'll go into the calc menu. This time instead of the minimum, I'll use the maximum. And then my left bound has to be to the left of the maximum. So recall that our maximum is somewhere over here. So that's certainly to the left of it. I shouldn't say certainly. That's certainly to the left of it. And this is certainly to the right of it. And so I want to point somewhere up in here is my guess. Calculator thinks for a minute, and it spits out, hey, look at that. Very similar to this point I just found, which makes sense. There's a lot of symmetry inherent in this graph, except now it's negative 2.45 and negative 1.63. So that's the coordinates of this point right here. So yeah, they take you through all this. There's some screenshots that look kind of like mine. I'm curious. I guess I didn't even figure out what this question was asking. Maybe I should have done that first. Then graph this function, then use the graph to estimate the local extrema of the function, so that's this point and this point, and to determine the intervals on which the function is increasing. So that's kind of interesting, right? I got to figure out where it's increasing. Well, when we're talking about increasing, I always specify the x-coordinates. So it looks like it's increasing from -infinity all the way up to this x-coordinate right here. And the x-coordinate of this point is the -2.45. And then it's also increasing from this point all the way off to the right here. So from +2.45 off to infinity, something like that. And it looks like that's everything it asked me for, so I guess that's the answer, and I'll stop this here.